In this video, we'll be looking at the topic of sequences, which is section 5.1 in your textbook. A sequence is a list of elements called terms. Now, often those elements are numbers. They don't have to be, but in many examples they will be. One example of a sequence is 3, 6, 9, 12, 15, etc. More formally, we can define a sequence as a function whose domain is either all integers between two given integers or all integers greater than or equal to a given integer. That sounds a little complicated, but the idea of a sequence is we have this list of elements, these terms, starting with a certain value, and they may end at a certain point, or the sequence might continue forever. But because of the nature of this ordered list, we can talk about the first term, the second term, the third term, and that's the idea behind thinking of a sequence as a function from a set of integers. Now, terms of the sequence are denoted a sub k. Here, k is called the index for the sequence. So a sub 4 would be the fourth term of the sequence. For example, consider the sequence defined by the explicit formula a sub k equals k plus 1 quantity squared for k greater than or equal to 1. So notice we have a formula. We also have a restriction on k that tells us where to begin the sequence. The terms of this sequence would begin with a sub 1, which would be equal to 4. A sub 2, the next term, would be equal to 9. And we could continue in that fashion using our formula. Now let's think back to the first example given of a sequence. 3, 6, 9, 12, 15, and so on. What would be an explicit formula for that sequence? I want to give you a chance to think about that. You might want to pause the video and write down a possible explicit formula for that sequence. So one possibility is b sub I equals 3i for I greater than or equal to 1. Okay, so we could see from looking at that sequence that these were multiples of 3. The first one was 3 itself. And so one straightforward way of expressing that would be 3i for I greater than or equal to 1. That's not the only way that you could express that sequence. So another possibility, c sub j equals 3 times j plus 1 for j greater than or equal to 0. Notice we needed to start j at 0 rather than 1 to define the same sequence. We might prefer one of those over the other. Maybe we want a nice simple formula. Maybe we want to start at 0 instead of 1. And there are a multitude of other possibilities we could come up with. If we look at these two examples, we can move from one to the other using the relationship between those variables. So using I equals j plus 1. We refer to that as a change of variables. And that's something that we can use whenever we want to go from one possible formula to a new possible formula. And we want to make sure that that new formula is completely updated to the new variable. We don't want a mix of the two. The next topic in section 5.1, which we'll get into in a separate video, is the topic of summations and products. These are important extensions of the concept of a sequence. Thanks for watching.